Hydrolysis of ethers is one of the important reactions in the ethers lesson. Let us see what happens in the hydrolysis of the ethers. Whenever you take any ether, this is general ether formula. So ether on acid hydrolysis, H plus and H2O usually disconnects this bond and provides the alcohol. All ethers on acid hydrolysis gives alcohol. You take any type of the ether. You just take the secondary carbon contained ether. This is R dash, H plus, H2O, RCH, R, OH plus R dash OH. Now let us take another one. Third one. The importance of this reaction you shall come to know after explaining this particular example. H plus and H2O. Because the mechanism is so important for this hydrolysis of the ethers. So what usually with that, what happens simply alcohol ether react with the water molecule in the presence of the acid catalyst, simply all they are producing the alcohols only. But these reactions means hydrolysis of the ether is a nucleophilic substitution reaction, and in this particular case this reaction follows SN2 mechanism, and this reaction follows SN2 mechanism, and this reaction follows SN1 mechanism. So let's try to know and which ether follows SN1 mechanism, which ether follows SN2 mechanism, and the reason why. So I'll write here. You must remember that whenever oxygen atom in the ether, whenever oxygen atom in the ether is connected to the, if primary alkyl groups are there, if only primary alkyl groups are present, uh, then it gives SN2 mechanism. If the ether is having either secondary alkyl groups or tertiary alkyl groups, any of these groups are present, then it follows SN1 mechanism. And if only phenyl groups are present, means both the sides, if both sides only phenyl groups are present, then see that there will be no hydrolysis. So you can understand how they are following SN1 mechanism and SN2 mechanism after seeing the reaction mechanism. So let us see the reaction mechanism of these ethers now. Mechanism of the ethers having the primary alkyl groups. So I will take the here CH3O, CH2, CH3. This is simple ether. So this particular ether on reaction with the H plus ion. So here ether is having the lone pair of electrons on oxygen atom. This attracts the H plus ion so that it forms the CH3, oxygen, hydrogen, again CH2 and CH3 here. So oxygen gets the positive charge. Now what happens is the water molecule, because we are adding the H plus along with the water molecule. So H2O, in H2O, oxygen having the lone pair of electrons. So this oxygen always preferably attacks over the sterically less crowded carbon atom. So this carbon atom is free from the larger groups. Why? Because it is having just hydrogens around it. But if it wants to approach this particular carbon, and this carbon is having the one side methyl group, other side this big group is there, so that it's sterically a bit crowded. And one more important thing here is, even if you see, this is a partial positive charged oxygen. Oxygen with a positive charge is unstable. So it try to withdraw the electrons from all the possible sides, and because of this, the positive charge shall be created over all these atoms that are directly connected to the oxygen. Imagine partial positive charge is connected over to this carbon and partial positive charge over this particular hydrogen and partially positive charge on this particular carbon. Don't think that sir, partially positive charge here and here they repel each other. No, there are chances for this oxygen to withdraw the electrons from the atoms that are connected to it. Then only charges shall be created over them. And in this particular case, you forget about this hydrogen. Now let's come to these two cases. Why? Because if you think that hydrogen oxygen bond is weak, so that if it retrieved back, then again you'll get the ether. So we are going forward direction, so that I am saying that you forget about the hydrogen. Now you consider these two carbon atoms. Now in these two carbon atoms, this carbon atom is having the partial positive charge both of these, and here methyl group is there that can release the electrons through its plus I effect. Because of that, the partial positive charge that is present over this carbon is less in comparison to the partially positive charge present over this carbon atom. So that these electrons will find more positive charge over this carbon rather than this carbon. Hence, these electrons can easily attack over this particular partially positive charged carbon, so that this bond shall be disconnected. Okay, so this step is a bit slow step. Hence, so in this particular step, attacking of the nucleophile, disconnecting of the bond takes place simultaneously. Okay, so what happens here is we get, I'll take this color. Okay, CH3 is connected with the oxygen, hydrogen plus, and second molecule. So second molecule is this part, CH3, CH2, OH, and from here there is a loss of H plus ion, so that finally CH3OH. So both alcohols shall be created, and this is the slow step, that is the rate determining step, and in this step both are participated, that means nucleophile as well as the ether, so that it is called the bimolecular nucleophilic substitution reaction. Now let's try with the tertiary alkyl ethers. So let's go with the molecule that is having the CH3, C, CH3, CH3, oxygen and CH3. So when it is subject with the acid hydrolysis, first step is same, that lone pair of electrons of the oxygen of the ether attacks over the H plus ion and forms the unstable intermediate like this. Here positive charge is created. Now if you add H2O, H2O will not attack in this particular step. The reason here is, now you can see the positive charge shall be created over this carbon atom, and the positive charge shall be created over this carbon atom also. So H2O can easily attack over this one, giving the tertiary alcohol. But the reason here is partially positive charge of tertiary carbon atom is though unstable. So though the partially positive charges are created, H2O can easily attack over here also. There is no doubt. But the question is, instead of the partially positive charged carbocation, fully positive charged carbocation is more stable, tertiary carbocation. So in this step, this bond will be disconnected and finally giving the tertiary carbocation. Tertiary carbocation with the CH3OH. So this tertiary carbocation will be attacked by the H2O in this particular step, so that giving the CH3, CH3, CH3O, hydrogen and hydrogen positive charge comes over here, and loss of H plus ion from here, so that we get the tertiary alcohol. And here so many things you need to observe. That is, first of all, this particular step, disconnecting of this bond is a slow step, and this slow step only ether is participated. Hence, it is a substitution unimolecular nucleophilic substitution reaction. So, because after that nucleophilic substitution is taking place, and the question to be asked is, whenever tertiary group is present in any ether, you must remember that this side primary group is present and this side tertiary group is present. If at least one secondary or tertiary alkyl group is connected to the oxygen of the ether, then it follows SN1 mechanism because their carbocations are more stable. In such cases, if you use the hydrogens, the hydrogen of the alcohol is from the water, not from the H plus. You must remember that. Okay. If only primary alkyl groups are present, then it has to follow the SN2 mechanism, and in that cases, the H plus ion shall be connected to the oxygen, and this oxygen, hydrogen both are with the larger alkyl group part. So I will take the deuterium combination so that you will understand more perfectly now. Say I will take the combination of the O, CH2 and CH3. Now you just use D plus and H2O. Okay. So in this case, D plus shall be attacked over here, and later this bond will be disconnected. So this oxygen along with the D plus means deuterium plus will be with the ethyl alcohol. So the molecule becomes now CH3, CH2OD plus later CH3OH. So this H2O molecule, oxygen and hydrogen shall be connected to the methyl group. At the same time, if you take the tertiary alkyl groups, now tertiary alkyl groups, you take the same combination of the reagent D plus and H2O. Now D plus will be with the smaller group here. So CH3OD, because here carbocation shall be formed on which H2O molecule will attack. CH3 means I am directly writing the product. Actually, there is loss of proton also later. So I am directly writing the products. So you must remember these crucial important steps. Okay. So now let us see some applications regarding this particular um, example. Some applications, important examples are there. So what happens if this undergoes hydrolysis? Because phenyl group is there, now I am taking the D plus and H2O. Always remember that never and ever try to disconnect the bond between the benzene ring and oxygen or benzene ring with the halogen. It is impossible. Why? Because the lone pair of electrons present over the halogen or oxygen participate in the resonance, so that breaking of this bond is not possible. So this oxygen shall be with the benzene ring. So D plus after attacking over here, this also shall be with the benzene ring only, and later H2O molecule will attack over the methyl group. So this is the basic information one has to remember. So this is OD plus CH3OH. Then what type of mechanism it follows? It follows simply SN2 mechanism. And the second one, again let's take the benzene, oxygen, tertiary butyl group. So either tertiary, secondary, if they are present, so what must be the mechanism of the reaction? It is always SN1 mechanism. Now I have taken the reverse reagent, means H plus and D2, reverse to this one. So this is OH, H plus and always with the phenyl group, CH3, CH3OD. Since when tertiary alkyl group or secondary alkyl groups are connected to the ether, if they are participating in the SN1 mechanism and they are forming the carbocation, so that carbocation means always you have to go for the rearrangement also, if there is a possibility of the rearrangement. And now H plus H2. So, what type of mechanism it follows? Everybody knows that it gives simply alcohol. That everybody knows. So, what I am asking is what type of mechanism it, whether it follows second SN1 or SN2 mechanism. So, is just to see the carbon connected to the oxygen. This is the secondary carbon, and this is the primary carbon. Secondary is present so that it follows SN1 mechanism. Though it is giving alcohol, but it follows the SN1 mechanism. So what type of mechanism they are following is so important in these cases. Now let us see some other abnormal conditions also and important examples also. On reaction with H plus H2. OH, OH we can write easily, but mechanism is important as here this is a tertiary group, this is a secondary group. So you can easily say that it follows. Now let us see a molecule H plus and H2. Simply you can say that there is no reaction, because the clue I have already given that here tertiary alkyl group, here also tertiary alkyl group. Very bulkier groups are present on both the sides. So impossible to hydrolyze this ether, so that there is no reaction. And let us see some simple one also I am taking. As you know this H plus and H2, OH, this is OH, and this is primary, this is also primary, so that this is SN2 mechanism. If you like this explanation, do not forget to subscribe the channel. Thank you.